Section 3.2, What's Unusual, the Empirical Rule, and Z-Scores. So the empirical rule is a really important rule that we're going to discuss in depth in this class. It's a rough guideline or rule of thumb that says if your distribution is unimodal and symmetric, so if it looks like the one below, then we can say that approximately 68% of your observations should lie within one standard deviation of the mean. Approximately 95% of your observations will be within 2 standard deviations of the mean. And nearly all of them, and by all we mean 99.7%, will be within 3 standard deviations of the mean. So let's give ourselves a visual of what that is saying. So here we've got the mean being x bar. And then let's go up 1 and down 1 standard deviation. So that would look like x bar plus 1 standard deviation and x bar minus 1 standard deviation. I'm just going to use S for standard deviation right now. And what that means is that between those two values, between there, in this area in the middle, we should expect that's where 68% of our observations should lie. If we go out and back one more, go out 2 standard deviations, sorry, my lines are very crooked. What that means is that 95% of our values should be between there. And if we were to go out one more, 3 standard deviations in either direction, that means that 99.7% of our observations are within there. Just because you might need it for some of your homework problems, not because of anything particular that I personally would ask you, I'm going to give you some more broken down percentages in here that might be helpful for you. If there's 68% in this whole middle part, that means either one of those areas itself would be 34%. So 34% can be expected above the mean 1 standard deviation and 34% below the mean 1 standard deviation. And if we do a bunch of calculating and subtracting, it would mean that roughly 13.5% are right here and only 2.5% are on these tails past the 2 standard deviations out. So we've said in the past that anything beyond 2 standard deviations is considered unusual. So anything past these marks out here is considered unusual. And now we can really say, look and see why. It's because there's only a 5% chance of being in either of those tails and only a 2.5% chance of being in any one of those tails. So with only a 5% chance of being out there anywhere, that's why we say anything out there is a very unusual sight. Okay, let's use this rule to decide whether it's unusual in San Francisco to have a day when the high temperature is colder than 49 degrees. And we have to recall from our prior section here that the average was, or the mean is 65, and the standard deviation is 8. So why don't we work our way backwards, because 49 is a colder temperature. Let's work our way backward. If we go backwards 1 standard deviation, if we subtract 8 from there, we would be at 57. So it's definitely past 1 standard deviation out. If we subtract 8 again from that, we would be back at 49. So a day colder than 49 degrees is somewhere back here. It's somewhere past 2 standard deviations below the mean. If we compare that with what we had up here, being past that 2 standard deviations below, there's only 2.5% of days that would qualify for that. So I would say yes, this is very unusual. Sorry. I would say yes, this is unusual because only 2.5% of days have temperatures this low. So to me, that would be unusual. And in general, that is considered unusual. If you're past 2 standard deviations out in either direction from the mean, we classify that as unusual. So that's what we're saying here. Any observation past 2 standard deviations out is unusual, because honestly, only 5% total of your observations fall out that far, 2.5% on either end. Now we do have a need for standard units. So you're going to see what's referred to as a z-score. A z-score is a measurement converted to standard units. You do need to know this formula right here. You will need to know it and be able to calculate z-scores, but it's not a super difficult formula. You just take the value that you're interested in, you subtract the mean, and you divide by the standard deviation. All that does is it changes the grid or the numbering system that we're going to use on our images here, on our distributions. And we're going to have 0 in the middle. So instead of like up here, how we put a 65 in the middle and then we counted backwards from there, to standardize that and to make the numbers easier, we'd like to start counting in the middle at 0. And then what it does is it makes it so that if I go up 1 standard deviation, that just is symbolized by 1, and up 2, and up 3, and on out. And then if I go back 1, back 2, back 3, those are symbolized with negative numbers. So it just standardizes the numbers that we're going to use on the bottom, so they're not varying all over the place from problem to problem. So a z-score just tells you how many standard deviations your observation is from the mean. And a z-score lower than -2 or higher than 2 is considered unusual. So it makes these questions just a little bit easier and faster to ask. Okay, let's see. Maria scored an 80 out of 100 on her first stats exam and an 85 out of 100 on her second exam. On the first exam, the class mean was 70 and the standard deviation was 10, and on the second, the class mean was 80 and the standard deviation was 5. On which exam did Maria perform better when compared to the whole class? Or another way of asking that same question is, which score was more unusually high? Because it was definitely, both of her scores were higher than the average. Which one was more unusually high than the other is what our question is. So anytime you are asked which is more unusual, it's best and fastest to just calculate the z-scores. So the z-score for the first test would be to take the 80 that she scored, subtract the mean on the first test was 70, and divide by the standard deviation, which was 10. So we'd get 10 over 10, or 1. 1 is the z-score there. So 1, her first test falls right here. She has 1 standard deviation above the mean. So that was test 1. Let's do test 2. Test 2, the z-score would be, she got an 85. The average was 80. Standard deviation was 5. 5 over 5, or 1 again. So her second test landed right there as well. So neither of her tests was any farther away from the mean than the other one. So neither of them was more unusually high. They were exactly the same. So I would say something like neither. She actually performed equally as well on both tests relative to how the whole class performed. So the whole class did better on the second test, and their scores were less spread out. So the fact that she did a little bit better on it as well doesn't really show a difference in her personal performance. Okay, this says, assume that women's heights have a mean of 64 inches, which is 5'4", and a standard deviation of 2.5 inches. What woman's height would correspond to a z-score of 1? So we definitely need to use that z-score formula again, but this time we know a different portion of it. We know the z-score is 1. We don't know the value that we're looking for. So it's something minus the mean over the standard deviation. So I need to solve this for x. So I do have to dig back into my algebra toolbox here to solve a fractional equation like this. The first thing I'd want to do is multiply both sides by the denominator to cancel that out. And then I could add the 64 over. So I would get 66.5 in this case. What woman's height corresponds to a z-score of negative 1.2? So that's going to be the exact same calculation steps, just with a different number over here. So I'm going to multiply. That gives me a negative 3 over here. And then when I add, I get 61. So these are their z-scores, these are their actual heights. And which one of these is more unusual and why? Is it more unusual for a woman to be 66.5 inches tall or 61 inches tall? Well, I would go back to the z-scores for those and compare those. So one is 1 standard deviation above the mean, and the other one is 1.2 standard deviations below the mean since it's negative. But it's the fact that this one is farther from the mean that makes it more unusual. So I would say 61 inches because it's farther from the mean.